Hello, everyone, and a very warm welcome to all of those behind the screens. My name is Lars. I'm with the eurolaser company now for 6 years, and my responsibility is sales in Germany for the zip code 2, 5, and 6. Co-worker of mine, Pascal, he's an application engineer, and he will show us today the hardware for what we are going to present you. I just want to give you a rough agenda. What we are going to present is the soft and signage solution from eurolaser to cut and handle large format prints and signs. Therefore, we prepared some of our machines here in the demonstration lab where we are normally doing the customer pre-testing. Pascal, the L1200 conveyor standing right behind us. Can you give us a short impression about that particular machine?
Yes, of course. So today we will be using the L1200 conveyor system, which is equipped with a feeding unit in the back. So the material that you can see here is fed automatically onto the system. It's equipped with a laser pointer and an edge alignment tool, which brings the material always in one line and flat onto the system. When the material is onto the system, the material lays on a bed wire mesh. As you can see here, for example, this is the wire mesh that we are using today, which is the thinner gap one, so the half mesh size. In comparison to that, we as well have a full mesh size. The difference between them is just that for the smaller mesh, we will use thinner and lighter materials, such as material for parachutes. So the vacuum doesn't pull the material that much into the gaps of the mesh. When the material is cut from the table, it moves to the collecting table, where you can collect all your pieces while the system is still cutting. So you have no downtime. In the end, you can always collect your pieces, even when the machine is fully running. From there, your material or the waste of your material falls into that rack here, which you can collect all your waste and then throw it away in one go. The system here is equipped with a 250-watt source from the company Luxina, which is one of the two companies from sources we will use for our laser systems. And on the back, which would we highlight in this webinar, is the camera on the back of the beam, our new camera system.
Let's have a look behind the machine to show all those interests. The scanner over there.
Yeah, so as you can see here, there's the line scanner, which is equipped with cameras, and on the bottom side there's a light bar, which allows you to have perfect lighting anywhere in your room. Even if you have no lights above the system, the image will still come out clear and have a good contrast in the end. Yeah, that's the system we will be using today.
So what we can see here, the print looks like old school. Old school means to me that we have all those reference points around each single print. In the past, a single camera was collecting all those reference points over here, and several of them were used to calculate the position and the shrinking for each single flag. In this machine, we are talking about, we're having here about 80 reference points. If we are going later on to our 3XL 3200, the machine has a working area about 3.2 by 3.2 meters. And when the machine is fully covered, we can have easily more than 400 up to 600 different kind of reference points. And you can imagine that the recognition of all those points by a camera could take up between 12 and 15 minutes in what we call the old school way. Nowadays, with the camera system, what Pascal explained as a PPP, position professional.
So the scanner will scan one of the or the whole table, and then gives me a picture onto the software where I can choose from different options to work with the system. I can either use the reg marks, just like the old school way, but it scans it in one go and position all your files onto the cutting table, or you could use the contour itself. For example, if you have that flag right here, it will collect the data from the outside of the flag, and you can get your contour created right on the go on the system, and then cut it out just by the shape of the contour that's laying on the table.
But therefore, it would make sense to have a black outer frame around, especially if I look down to your area over there. There's a green, white, green to the non-printed material. There's not a big contrast, so therefore it would make sense to have a black outer line around, and without having no printing information, the scanner easily can find every single flag, and then you can decide if there should be a positive or negative offset, or should it be cut at the zero position, whatever. I could see a barcode over there. What does this make sense?
So when you have a barcode or a QR code, which has the name of the file on it, you can scan your whole table and then get your file automatically get collected from the bar or QR code from the textile on the cutting table right now. It's automatically imported onto the software, so you can get it from like a hot folder or whatever, or wherever your data is stored. You can just pick it up and then it gets loaded into the software automatically.
Nice. So the possibility about having human mistakes over there is mostly completely deleted. The camera is looking at a particular position, reads the information, it's loading the cutting files, which comes from a RIP software, then it cuts out, especially known how many prints are on the complete roll, and you can get an estimate machining time which says forecast would be about, I would say, 23 minutes. Yeah? Okay, Pascal. Then let us see how the laser works.
Yeah, so enough of explaining. We can get a look onto the software real quick, where I can show the scan right now for the table. So as you can see here, that is my table on the system, which is scanned, and the contour is automatically placed over those flags right here. And then if I have my contour, I can either do it manually, as right now, we put everything on there manually with parameters, and then you can just select to cut. And
Pascal,
then
I don't like to interrupt you, but I have seen on your screen that the reference points which will be located by the camera are not completely fulfilled. Therefore, we have open reference points. How can the machine realize open reference points? We especially look to the number 82. This is not a complete round reference point. The software still can use it.
yeah, so when you scan it with the Position Plus Professional, you always have the possibility to set your target that you want to scan for. For this example now, we are scanning for black reg mark dots, but you can always set a threshold to get the marks that look exactly like the one you're searching for, but close to it. So for example, now this material is pretty hard to collect the reg marks of, because it has that much dots in there which interrupt the reg mark points. So it's good to have a camera like this who can collect even those marks on your table. So right here, we have the finished cutting piece. This especially now is pretty big. So I'm gonna hold it like that. So you can see everything is cut out perfectly. Looks good like that, and even the detail view, if you want to look at it, has a nice cutting edge. No burning marks, no yellowing. Looks really good on there.
So even the advantage about the sealed edge, it's stiff. I can pull over there, I can move, and it stays the way like it is. Yeah. So laser cutting with PPP scanning camera. Pascal, we have additional advantages if we are talking about a eurolaser. For example, on my right hand over here, I can see a lot of digital tools. Can you just give us an impression about what we can do with the eurolaser more than just scanning and laser, cutting by laser?
Yes, of course. So right here, we have all the extra tools that are available on the eurolaser system. Because the movement system is based on a Zünd system, we are able to put many different tools on the second or third slot. So for example, if we start from the left here, this is a routing module.
Give us a small break. Finn, just come with me that we have a view on the machine over there that the attendees are understand what we are talking about, 1, 2, and third place. So first place is always the laser on. In this case, the second place is empty. And on the third place, we have a single cartridge for the printing solution. And those could be exchanged pretty easy and pretty fast. We are talking here about less than a minute. And so therefore, we can exchange different kind of tools for having different kind of solution, what Pascal will have shown now here on a 3S machine.
Yeah, so we did stop right here at the routing module. This is a 1 kilowatt routing spindle, which you can install there. Right next to it, we have an ink marking module, which is made for sewing lines, just a small ink sprayer, basically. Right next to it is a pneumatic knife, which is oscillated by the pressure of air. Next to that, we have a 300 watts routing spindle, so the smaller size, which is used for thinner or easier materials. Next to that, we have a labeling module, which could be interesting for traceability. In combination with the printer next to it, you are able to do something like that, to print a label on a textile, and then even print it with a QR code or traceability numbers, production batch number, when was it made, something like that. Or you even have the possibility to get an NFC tag in that label, so you can scan it with your phone or any device where you can put your traceability details in as well. Yeah, so these are the 2 printing tools. We have one with 3 cartridges where you can print larger format, or just a single cartridge, which is printing about 12 millimeters.
So if we are talking about printing, we are just have the possibility about marking our cutting parts. We are not printing whole coils, frames, bars. We don't do.
Yeah, it's just
marking.
It's just writing or letters or something like that. So only for like traceabilities, not for real printing whole like sections of the material. Yeah. Then next to it, we have an empty module, which is fitted for multiple different tools, such as different knives, like an electric oscillating knife, a 45-degree knife, a kiss cut tool for like thin foils, where you can just cut the top layer, for example, a driven rotary knife, or just stationary knives, which will be stable on one place and don't move at all, basically. As you can see here, which is installed right next to that. And that is an ink marking module as well. And these are about the, not the full modules that we can install. There's, of course, some more, but just a small variety of modules that we could install.
Perfect. What we have seen from here in the background is our eurolaser 3XL 3200 conveyor. And Pascal is now going to explain us what makes this machine so tremendous.
So, as you can see here, this is our biggest system available, which has a cutting area of 3.2 by 3.2 meters. Pretty good for large format printing. And to highlight our application right now, just for the Position Plus Professional, we have a small sample roll prepared, which you can see here on the old school variant, where you read every marks. You have to have a gap between your objects that you want to cut, where you need to place your rack marks. And on the optimized version, with a bar scanner on the back of the beam, you have the possibility to print them right next to each other, so you don't waste any space for objects that you cannot use, or where you have blank space. As you can see, you can nearly fit another whole object onto the roll without losing any material. And then, of course, the 3XL, the build-up stays nearly the same. It's the bigger system. So this is a G3 series, which is possible to install one more full tool instead of the S3. So you have the possibility to put 2 extra tools onto it. And in the difference between those two systems here as well, you have the white mesh conveyor belt, which is used for more stiff or stable textile materials that you can cut onto the conveyor. But the build-up nearly stays the same. You have the same options like the feeding unit in the back. There's the back beam scanner onto as well, and the conveyorized system stays the same.
Very nice. So now that we have those both machines in one room, I figured out that I have another watch on my arm, and it's not really a watch. This is what we called a remote pause button. So the opportunity of that tool is that I can be close to the machine. We're talking about a range about 100 meters, and I have the possibility to start and stop the machine with that button. So if I'm standing here right next and Pascal is working on that machine, and I can see from here that there's a wrinkle coming from the feeder, and I don't like to have those wrinkles, doesn't matter where they come from, I can say, okay, stop, the machine stops, I go over there, fix it, restart it. So I have a possibility to control 2 machines with 1 person, which are very close together. Other possibilities we have is that we are machining, testing your customer material. So if you are and you are not pretty sure about if your material could be by a laser, just get in touch with us, call us, send the material over, we will test it. You are also invited to join us during those tests. We are not doing this as a secret. So everything you are interested, just call us. With the laser and the camera on the conveyor system, we have the advantage about switch the camera, sorry. We have the advantage about getting the material unstressed onto the cutting machine. With the feeder unit, which is right behind over there, brings the material stress-free on the cutting area, and the laser, by not touching the material, is cutting it as it lays over there. The cutting sealed areas are very stiff. We have possibilities on how massive your material is, what you want to machine on the laser. On the 11th and 12th of September this year, we have our innovation days. Everything got emptied over here, and we set up a complete line where you can see how we are integrating our machines into a process line. Therefore, we have a sales out. The machines which are left over here will be. Vocabulary is missing. Das heißt angeboten, offered. I'm sorry. Will be offered with a discount about 30% right now. So if you are interested in one of those 4 machines, which are shown over here, just get in touch with us. We give you a very good information about what could be done with those machines. And then we are testing your material on our machines. Yeah, Pascal, any last words? May I miss something?
I think we can still show one more thing really quick with the camera system. Just to show how it works again, I would demonstrate one little scan.
Please.
To show how it's done in the end, and then I think we're good to go. So, as you can see here, this is the software we are working with. So the Position Plus Professional on the top. Here you have the possibilities to either do it in automation, which is then collecting the barcode and immediately starts to cut and then goes on till the roll is empty. Or you can do it by hand. Just I would demonstrate it now. Start the scan. The system drives forward, then scans the whole table. And then when you click process, you can see your whole table is scanned. All the rack marks are captured in one go. And then if you have the file right there, you can just load it into that and then place it by hand if you want to do that, or you can do it everything automatically.
Yeah. And I have one last thing over here. We have, due to our printing partners, those kinds of SWOT books where different kind of materials are shown. And for example, materials like for killing acoustics. Then we have materials like what you can see over here for outer advertisement where the wind is going through. We have material which is waterproof. We have material shown here in several ways. So if you are interested, we are getting you in touch with the right guys for getting your advertisement done. Thanks a lot. I hope you enjoyed our webinar about what we presented here. And I'm sorry. If you have any further questions, just let us know. The contact information will be presented later, especially for Pascal and myself. So, yeah. I hope you enjoyed. Give us a feedback, and then we will have the next webinar for, I believe, another theme, and then we can repeat it. Have a nice day. Yeah, if you have any questions or so, just what I have already explained. Write us an email, call us, or okay, I'm sorry. You can put it right into the chat in this room over here. So therefore you can put your questions in, and we are perfect. There are the questions. 250 watt is not needed. What is the
So right now the system is equipped with a 250 watt laser, but it's not fully needed. So you could, of course, use less power. Sometimes you have material that you need to cut slower sometimes, but this material is pretty light, so you don't need the 250 watt full power on that to cut it at max speed, which is 1000 millimeters per second. And then another question is, how does the software compensate or for shrink or stretching of the fabric? So on this case, we have two major variants for the camera system. One which is true to size, so you stay basically the same size, and the camera system just rotates your file the way the material is, for example, rotated, which will be the compensation method fit to job. And the other big one would be best fit, which gets all the information from the table of the fabric. And if there's any shrink or stretch, the material or the picture will be compensated. So your cutting is always staying true to the print and can change in size. So basically, you will always have the full print in one cut, but the size may change. So you need to figure out which would be the best for you. If you still need the true size to put it somewhere into, or to have a perfect fit for some materials, then you would need fit to job. And if you can change in size and just want the full print, then you would use best fit.
The conveyor belt is moving up from 0 to 700 millimeters per second. Standard speed is about 400 millimeters per second. This is a conveyor moving and feeding speed. We can adjust it. It depends on the material. If the material is stiffer than another, that means if I could bend the material a lot, then we are starting very slow, speeding up and stopping the same way. Start ramp, stop ramp. And if the material is stiff, I can start very strong and can break very strong without having any movement inside the material which comes from the feeder.
And there's another question that is coming: if we can cut Lexan material and up to how many millimeters? So we have a database with much materials, around 2,900 at the moment. We can look that up for you. You can either leave us a mail or get in contact with us anyhow, and then we will look that up and tell you with speed, for example, we could cut it, or would be the best method we would use to cut it.
If my roll is bigger than the machine width, is there any possibility to get it to the machine? So right now, our biggest machine has a width about 3,280.
This one right here?
No, the biggest machine.
The width.
3,200.
Yeah, that's right.
So if your roll is bigger than 3,200, we have a small additional gaps where your raw material, means the boundaries, can go underneath adjustment here. This is our what we called laser bar here, and the cutting area is for this machine 1,800. And if you are looking, Finn, can you come over here to just give me detail? Just have a look over here. So the cutting area from here to over there is 1,800. But this, which can go underneath the laser bar, is bigger. So we're talking about almost 2 meters. Yeah, but it cannot be cutted. Cutting starts here. So the free space is bigger than the roll. So if you are having a roll which is bigger, can we switch to the other camera? If we have a roll which is bigger than 3,200, we don't have a 5-meter system right now.
We have a solution for that. So if your roll is bigger than the size that the cutting table is, you have the possibility to install the edge trimming tool, which cuts your material on the go to the system. So while you feed it, the edges will be trimmed here with a knife blade, so your material can fit onto the system in the end. So if your material is wider than the system can fit right now, for example, now in this instance, the feeder is wider than our cutting area, we can trim those rolls. Of course, not by much, but a few millimeters would be always possible.
That was a nice idea. Okay, any questions left over there? If you're having a 380 kilogram roll, we can scale the feeder up to 1 ton. Yeah, 1,000 kilograms is no problem for us to put single coil onto that feeder, no problem. So if there are no other questions, we will stop the live. I got a sign from the background. Yes, of course, we can work from roll to roll. That means what we discussed so far is that the raw material is coming from the back over here, going down to the machine, here, cutting area, and then we are going to what Pascal called the collecting area. But if we are not cutting the material 100% through, what we can do, for example, we have very, very small thin positioning holding strips inside. Then we have the possibility. Now, Finn, we both together. We have here a winding solution. The winding solution brings you up the material from the laser cutter, the collecting area. The cutted material is still inside the raw material, and then we have the possibility to wind this up. So the whole coil could be shipped to the customer. He can put it on a stable rack, put it out, and then he can just take the single cutted elements out by hand, or if there's a little bit stronger the holder, then we have to cut it out of the frames. Available, standard tool. Yeah. Yeah. The question is it possible to adapt the depth of the laser cutting, so not cutting completely the material? This is what we called and now I got kiss cut. It's a kiss cut solution. So what we have over there is, if I got a foil with 4 different layers, can I have thin camera? If I have a foil which is made out of 4 different kind of layers, yeah, they are glued together or they together, and I come with a laser from this side here, I can easily adjust the laser just to cut the first and the second layer, and the laser will stop at the 3rd layer right over there. And we're talking here about possibilities that we have about 10 to 15 microns adjustable depthness on that foil. So I have a foil which is, in this case here, I would say 5/10 of a millimeter. I can exactly cut different kind of layers where I want. The most important thing is the CO2 laser is always acting on the surface. I can't just cut layer number 2 and 1 and 3 are virgin. No way. If I start from the top surface, I can decide how deep I'm going, even if I cut it through. Yeah. So the depth is adjustable. What we have another. Okay. So, no more questions? We really appreciate. Hopefully you had the same amount of fun we had. Or the guys right behind, they are laughing. So, we're saying goodbye. See you next time. And hopefully we can get some very nice contact out of this webinar. Have a good one and bye-bye.